Question 11a says the curve has equation. The curve has equation y is equal to 2x cubed minus 9x squared plus 12x plus 8 Then 11a1 says find the coordinates of the stationary points of the curve. Okay, stationary points. To find the stationary points, first of all, we differentiate this equation once and then equate it to 0. Okay, because the grad dy over dx will be equal to, differentiating this will be 6x squared minus 18x plus 12. Because the gradient dy dx is just simply the gradient. The gradient at stationary points is equal to 0. Okay, so we can divide this by 6. Then this is going to be equal to x squared minus 3x plus 2 is equal to 0. Then, x squared minus x minus 2x plus 2 is equal to 0. Because the product is 2, the sum is negative 3, and factors will be negative 1 and negative 2. Okay. So x minus 1 minus 2, x minus 1 is equal to 0. So if a stationary point will be x minus 2, x minus 1 is equal to 0. So x minus 2 is equal to 0, or x minus 1 is equal to 0. So x is equal to 2 or x is equal to 1. Then we replace these figures into the original equation, which is y is equal to 2x cubed minus 9x squared plus 12x plus 8. Okay, so when x is equal to 1, my y will be equal to 2 1s cubed minus 9 1 squared plus 12 1 plus 8. So this will be equal to, this is just 2. Then this will be just be 9, this will just be 12. Okay, so 2 minus 9 is 7. 7 is negative 7. Negative 7 plus 12, that would be 5. 5 plus 8, that is 13. So this is our first point. Then when x is equal to 2, y will be equal to 2 cubed minus 9, 2 squared plus 12, 2. Y will be equal to, is 8 times 2 is 16, minus 4 times 9, that is 36, plus this is going to be 24, and this is going to be 2. So y is equal to this, and this, that will be 20 plus minus 24, that will be 4 plus 2. 4 plus 2 is 6. Okay, so that will be 2,6 and 1,13. All right. Yeah, and then we go on to okay. Then it says determine the nature of the stationary points. Okay. So to determine the nature of the stationary points, we differentiate the equation twice. Since we already have the first derivative right here, the first derivative, dy over dx is equal to 6x squared minus 18x plus 12. Then d2y over dx squared is equal to, this is going to be 12x minus 18. Okay, so first we plug in the x coordinate, which is 1, then we'll plug in x, which is 2. So for x is equal to 1, that will be 12, 1 minus 18 is equal to 12 minus 18 is negative 6. So at this point, it is a maximum. Then the 2y over dx squared is equal to 12x minus 18 is equal to 12. 2 minus 18, that will be equal to is 24. 24 minus 18, that is 6, which is a minimum. So it is maximum at x is equal to 1 and minimum at x is equal to 2. So that is our answer. Then for question 11b, says find the coordinates of the points where the curves y is equal to e x over 2 minus 3 and y is equal to e 7 minus 3x minus plus 3x. Okay. At the point where they meet, they have the same y coordinate. So in short, this equation is equal to that equation at that point. So e is equal to x over 2 minus 3 is equal to this e7 plus 3x. Okay, so same base, so they cancel. X over 2 minus 3 is equal to 7 plus 3x. So this is going to be x over 2 minus 3x is equal to 7 plus 3. So this here is just going to be equal to 3 over 2 x 5 over 2x, yeah, 5x over 2, then negative, then it will be equal to 10. Then to get rid of the fraction, we multiply negative 2 over 5. So x will be equal to 5 times this, that will be 10 divided by 5, that will be 2. 2 times negative 2, that will be negative 4. Okay, so we replace in one of these. So y is equal to I'll replace it in this one. So e7 plus 3 will be negative 4. Y will be equal to e 7 minus 12. So y is equal to e negative 5. Y will be equal to e or 1 over e to the power 5. Okay. So the equation is negative 4, 1 over e to the power 5. So this is the point at which they meet. And then it says on the gradient of each curve. So to find the gradient, we just differentiate. Okay, so when we differentiate, when you're differentiating e to the power f of x, y is equal to e to the power f of x. Dy over dx of this is just f prime of x, which is just the differentiation of this function here multiplied by e with the same function there. So in short, in this case, for y is equal to e to the power x over 2 minus 3, f of x is equal to x over 2 minus 3. So f prime of x, the differentiation of this is just 1 over 2. So in short, dy over dx of this equation here is 1 over 2 e the power x over 2 minus 3. Then for this one here is equal to e7 plus 3x. F of x is 7 plus 3x. So in short, f prime of x will be equal to 3. So the differentiation, the gradient equation is just 3e7 plus 3x. Okay. Then at this point, so we plug in the x value, which is negative 4. So dy over dx will be equal to 3e7, or 7 plus, sorry, 3 negative 4. So this will be equal to, okay, dy over dx will be equal to 3e, this is going to be negative 12, then that will be negative 5. So negative 5, then dy over dx is equal to 3 over e to the power 5. Okay, so this is our differentiation for this one. This is our gradient at this point for this equation. Then for this other equation, it will be 1 over 2 e negative 4 minus 3 over 2. Then this is going to be equal to 1 over 2 times, this is going to be negative 2 e to the power negative 5 to be equal to 1 over 2 times 1 over e to the power 5, which will be equal to 1 over 2 e to the power 5, which is dy over dx, that other, or this other equation here. Question 12. Question reads, given that y is equal to, okay, given that y is equal to x plus sine 2x, okay, find the values of x for each dy dx. Okay, so dy over dx is equal to 0 for the range 0 is less than or equal to x less than or equal to pi. Okay, so first of all, since we've seen that the range is in rads, so we switch our calculators to rads. Then okay, so first of all we differentiate. So dy over dx of this will be equal to, for x that will just be 1 plus, for this one, for sine, when you're differentiating sine, okay, sine 2x, when you're differentiating sine 2x or sine 2x, first of all you say okay, let's just do this, forget this. So y is equal to sine 2xi. So let 2x be u. So y is equal to sine u. Then when you're differentiating, okay, when differentiating trigonometric functions, just know that it goes in this way: sine, cos, negative sine, negative cos. Okay, so when you differentiate sine to become cos, when you differentiate cos it becomes sine, negative sine. Then when you differentiate negative sine it becomes negative cos. When you differentiate negative cos it becomes sine. Then integration goes in the opposite direction. Okay, so y prime, which is the differentiation of sine of y, that would be cos u. And then u is 2x, so u prime will be equal to 2. Then to find dy over dx to be, this is just the same as dy over du, then this is just the same as du over dx. Okay, so that is dy over du times du over dx, which is going to be equal to cos u times 2, which will be equal to 2 cos u, but we know what u is, so 2 cos 2x. So that's what we're going to put here. Okay, so here, sorry. So the differentiation of this one is 2 cos 2x. That's the derivative of this. Okay. Then we've been told that this is equal to 0. So 0 will be equal to 1 plus 2 cos 2x, which looks familiar with the other equation that we had previously. I think that was number is it 6, 7, somewhere there. I think 6. I think that was number 6. Yeah. Okay. So to solve this, first of all, we take the one this side. So be 2 cos 2x. Okay, plus 1 is equal to 0. I'll just rewritten it. So this is just going to be 2 cos 2x is equal to 1 or negative 1. Then cos 2x is equal to negative 1 over 2. Since we multiply by 1 over 2 to get rid of the 2 this side, bring, yeah, so it will be that. Then this is going to be 2x is equal to negative, cos inverse of negative 1 over 2. Then x will be equal to cos inverse negative 1 over 2 over 2. Okay. Yeah. So, okay. So that is our equation. I've just made x subject to the formula. Okay. Now to solve it, x will be equal to cos inverse of negative 1 over 2. Okay. So cos inverse of 0.5. Mind you, this should be in rads. Okay. So cos inverse 0.5 will be equal to 1.047, okay, divided by 2. So x will be equal to 1.047 divided by 2, which is 0.52. Okay, right. All right. So these, since we had a negative here, we have to find the values of x that are, okay, it means cos is negative. So if when cos is negative, okay, cos is negative in the second and third, in the second and third quadrants, yes. So in the first quadrant, or in the second quadrant, x will be equal to pi minus 0.52, which will be equal to, so it is pi minus 0.52, which is 2.62. In the other quadrant, you add pi, and since we've been given this range here, it should be less than pi, so we just end here. So this is the value of x. This is the answer, rads. Okay. Okay. Then we go on to question 2. Okay, so we now go to question 12, 1b. And the question says, show that the area of the plate, the diagram below shows a metal plate consisting of a rectangle of length y centimeters and width x centimeters, and a quarter circle of radius x centimeters. The perimeter of the metal plate is 60 centimeters, which is this here. And then show that the area of the plate is a centimeters, or a centimeter squared is given by a is equal to, so we should show that it's given by a is equal to 30x minus x squared. Okay. Okay. So what we're going to do here is I'm going to find the perimeter. The formula for the perimeter. Perimeter is just the distance around the shape. Okay. So the perimeter will be equal to this x here, x, plus this y here, y, plus this y here, y, plus this x here, x, plus, then we have a sector here. And we know the perimeter of a sector, the distance of a sector, distance from here to here, will just be given by theta, r theta, because distance of length of a sector is just r theta. Okay. Yeah, from circular measure, that is the distance of the the sector. Okay. So perimeter is 60. Then x plus x x plus x will just give me 2x, plus this and this will give me 2y, plus our theta here, since this is a 90-degree angle, since this is a 90-degree angle, we know that in radians, 90 degrees is just pi over 2. Then my r, the radius, is just x. So this is our formula for perimeter. Then let's make y the subject of the formula. So that will be we'll take this side and this side. So 60 minus 2x minus pi x over 2 is equal to 2y. Let's multiply everything by 1 over 2. So y will be equal to 30 minus x minus pi x over 2. Okay, so that is our y. Then to find the area of a rectangle is just, that is the area will just be area of the rectangle plus area of the sector. Okay, so that is the total area, which is just what they wrote as A, so I'll just write it as A. Okay, so A is equal to, the area of the rectangle is just length times breadth, and length times width. Our width is x, then our length is y, and y is this, so that will be x, which is our width, times y, which is our length. It's x minus pi x over 2. Okay, then plus the area of the sector. Area of the sector is just half pi r squared theta. Yeah. Oh, sorry. Half r squared theta. Yeah. Half r squared theta. Okay. Okay. So area will be equal to x times this, that will be 30x minus x squared minus pi over 2 x squared plus 1 over 2. Our radius is just x, so x squared. Then our theta is pi over 2. Okay. So area will be equal to 30x minus x squared minus pi over 2 x squared plus this and this, that will give me, okay, this is x squared, then x squared times 1 over 2, that will be, okay, so 1 over 2, then this is x squared, then this is pi over 2. Okay, so this time this is just x squared over 2 times pi over 2, then this is going to be pi x squared over 4. Okay, so this is going to be pi x squared over 4. Okay, pi x squared over 4. Oh, sorry. When this was multiplied, this is going to be this times this is supposed to be a 4. So over 4 over 4 over 4. Okay, so this one and this one subtract, that is 0. They are like terms, so that will be 0. Then area will be equal to 30x minus x squared. Okay, so hence shown. Alright, then given that x can vary, find the value of x at which a is stationary. Okay, so since a is stationary, to find the stationary point of a minus x squared, we just differentiate dA over dx. dA dx will be equal to, when we differentiate this, it will be 30 minus 2x. Then, since it's stationary, dA over dx, which is the gradient of this equation, is 0 at this point. At a stationary point, the gradient is 0. So 0 will be equal to 30 minus 2x. So 2x is equal to 30. So x will be equal to 15. This is multiplied by half. 15. Okay. Then and then the question goes on, find the stationary value of A and determine whether it is a maximum or minimum. To find the stationary value of A, we just differentiate this equation. Again, we differentiate twice. We find the 2A over dx squared. So that will just be equal to, we differentiate this equation here, that will be 0 minus 2. So d squared A over dx squared is equal to negative 2. In short, it is a maximum. Okay, at that point, it is a maximum. Okay. So what we're going to do is, so for an AP, term number 8 is just equal to, the nth term of an AP, or the formula to find the term, is A plus D n minus 1, like this. So A plus D, our n is 8 minus 1. So T8 is equal to A plus D, this is 7. So term number 8 is equal to A plus 7D. Then term number 5 will be equal to A plus D, 8 minus, 5 minus 1. This is the fifth term, 5 minus 1. So T5 is equal to A plus, so that will be 4, so that will be 4D. Okay. So, since this is what we've been given, we will equate the terms. So, term number 8 is just A plus 7D is equal to 4 times term number 5 is A plus 4D, like this. A plus 7D is equal to 4 times A is 4A plus 16D. Okay. Then we've been given another clue which says the sum of the first 8 terms is 20. So we know that the sum is given by n over 2, open brackets, 2a plus n minus 1 d, close brackets. So S8 will be equal to 8 over 2, and be 2 a plus n, which is 8 minus 1 d. Okay, so S8 will be equal to 4 times 2a, then this is 7, so plus 7d. So S8 will be equal to 8a plus 4 plus 28d. And we know S8 is 20, so 20 is equal to 8a plus 28d. So this can also be simplified into this. So these terms, this side go this side. So that will be, when a goes this side, that will be 3a. When 7 goes this side, that will be 9d. Okay, 0. Okay, so we'll solve this equation and this equation simultaneously. So that is 8a plus 28d is equal to 20, and 3a plus 9d is equal to 0. Then that will be 8. Okay, so that will be 24a plus 28 times 3. 28 times 3, it will be 84. 84 is equal to 60. Then this would be 24a plus I think that is 72. I think 9 times 8, yeah, it's 72. 72d is equal to 0. Okay, subtract. So this is going to be 84 minus this will be 12d is equal to 60 over 12 over 12. So d will be equal to 5. Then I'll substitute in this equation 3a plus 9d is equal to 0. So 3a is equal to 9d, oh sorry, negative 9d. 3a is equal to, over 3, negative 9d over 3. A is equal to negative 3d, that is a. So a is equal to negative 3, d is 5, so a will be equal to negative 15. Okay, so now we have the first term and the common difference. So you can find the 10th term, the S10. So S10 is just equal to 10 over 2 in brackets. As in using the formula, Sn is equal to n over 2 2a plus d open brackets n minus 1. Okay, so 2 a is negative 15 plus d which is 5, then n is 10 minus 1. This will be equal to 5. This time this is like negative 30 plus this, and this is 9. 9 times this is 45. So 5, this will be 15, will be equal to 75. That is S10. Okay. Then question 12, 2, B1 says the second and the fifth term of a geometric progression are 1 over 18 and 4 over 235. So the second term, so T2 is just AR n minus, or 2 minus 1. Since the nth term, the formula for a geometric progression is Rn minus 1. So this is just going to be equal to T2 is just equal to AR. Then T5 is just equal to AR n 5 minus 1, which will be equal to AR for T5, just that. Okay. So we've been told that our T2 is just 1 over 18 AR, then our T5 is just 4 over 243 is equal to AR to the power 4. That's our fifth term. Okay. So we make okay, let's make A the subject of the formula. So A is equal to 1 over 18. And then to make A the subject of the formula, we just multiply by 1 over R. So we multiply this by 1 over R, that will be 1 over 18 R. So we now substitute in this equation. So that will be 1 over 18 R is equal to AR the power 4. Oh, sorry. 4 over 243 is equal to 1 over 18 R the power 4. We put this where is A. Okay, so 4 over 243 is equal to this and this, that will be R cubed. So R cubed over 18. R cubed over 18. We cross multiply this. That will be equal to 243 R cubed is equal to 18. 18 times 18 times 4 is 72. 72 over 243 over 243 r cubed will be equal to 72 over 240. Sorry, cube root r will be equal to, this is the cube root of 72 divided by 243. Okay, that is 2 over 3. So 2 over 3. That is our r. Then okay, then find the first term, a over 18 r. So a is equal to 1 over 18, 2 over 3. A is equal to 1 over, this into this is 6 times that will be 12. Okay, so our first term is 1 over 12. Okay, so that was our question B11. Then our question B12. Question B2 is the sum of the infinity of the progression. Okay, so the sum to the infinity of a geometric progression is just 1 over 1. Oh, sorry. 1 minus r. 1 minus r. So that will be equal to 1 over 12 divided by 1 minus 2 over 3. It will be equal to 1 over 12 times, divided by, this is just 1 over 3. So 1 over 12 times 3, it will be equal to 1 over 4. So this is the sum to the infinity. Okay guys, thanks for watching and have a great day.